Hello everyone who actually joined for this one. Was making sure that everything was working correctly because it's the first time I try anything like this with Twitch, or honestly with anything but screen shares, because that doesn't be my thing. I hope you're all hearing me right. If not, please leave a message. And I'm looking for my own pen, this over here. So to try whiteboarding today, let's try Microsoft Whiteboard, which seems to actually be a fairly decent piece of software for what I've seen, to everybody's surprise. But most importantly, it supports the pen, so I can actually use the pressure sensitive pen for it. Yay! So what are we going to do today? Mostly trying to randomly chat over some of the things that I've been working on, electronics related, and the stuff that I've drafted on the blog that I spoke about before, but that are not quite set in stone and I don't quite have working yet. And in particular, I may have a bad PCB because I got the signals wrong. So let's try to talk a little bit about that. This is a problem that we've been having less so, to be honest, lately. It may have been, well, not quite fixed, but improved by some of these things. And the problem is with our TV. So also shout out to the Noun project that has lots of nice icons, Creative Commons licensed, which means I can use them here, which is good. Not what I wanted. So selection. So I'll put cannot move that one. Our TV has a problem. It is connected to a receiver, which I have here. There we go. And it is connected to an HDMI switch, and then it is connected to a bunch of other things. The HDMI switch doesn't have an icon, so I'm going to put it here, and it is a 5-wave switch, and this is a switch. These are connected, of course, with HDMI TV, and then this one is connected eventually with the Chromecast, and the port of the and a bunch of other things over here. I think I have the Apple TV on that one. This one is connected in turn to the insert another image. This one, will it go the wrong place? Can I actually select it? Can I? No? Oh, that's annoying. Okay, so let me zoom this out. I think I can do it this way. By the way, I have to switch to the mouse to pan around because that doesn't seem to work with the pen, and it still goes to the place I don't want it to. I'm going to do it this way. Better. So yeah, we still have an HDMI connection here, and then there are more HDMI connections. So the green one is HDMI. And yes, it's terrible drawing. The problem is sometimes when the switch is selected, the receiver doesn't get turned on. And so you're actually watching something, there is no audio. All the audio should go through the receiver, and instead it goes nowhere. The receiver is selected for the audio, so the TV doesn't turn on its own speaker, but it doesn't turn on the receiver. The solution for that has been mostly the one to switch over the audio off and back on, which is feasible. It's a bit annoying, but it is feasible. But then it turned out there is an easier way, which is switch between the receiver that actually works with the switch that doesn't, and then back. So essentially just changing the inputs of a TV, fiddling enough with it, try enough times, it will work. and that's the current plan. Now, this is a NAC, so this is, let me write it to the side, this is a NAC, HTPC, NAC. So this one has working Ethernet, let's say just Ethernet. It's not actually Wi-Fi, this one is connected on cable, and then it has HDMI CEC, which is the consumer electronic control that allows it to control the TV. So these have a working CEC. The switch doesn't. The receiver kind of does. HDMI CEC, not quite. It has Ethernet as well. And the endpoint is actually SOAP of all things. For those who don't know it, it's a fairly old XML-based RPC system, so you can actually control the receiver and you can select the inputs. The TV has CEC, of course, but that's about it. It doesn't have anything else, and of course this one has CEC, and this one I think has CEC, but the switch has no CEC. The switch is controlled through an I already used the green for something. Let's use the blue one. The switch has an IR-based control, so it's essentially it's an IR remote control, and so does the TV, of course. Important to note, many TVs have serial or Ethernet. Sorry for the sirens. The software is Microsoft Whiteboard. It doesn't actually show. Oh, too bad. It's Microsoft Whiteboard, the Windows 10 version, which is free to use and included in Office 365. Works with a sensitive pen, which is nice. So let's see how this one will work out. As I was saying, the TV doesn't have serial control. Many TVs, particularly those that are often used for displays, for signs, for things like that, for dashboards in offices, will have a serial-based control, so you can select inputs, change the audio, change the volume, turn it on and off. Essentially with RS-232, some of which are documented. I think we did I forgot which panel. I think the Panasonic panels, I think, actually have a documented protocol for that. Some Sony have the serial port, which you're not supposed to have access to, but you can. This one doesn't. This one has, at best, an Ethernet port on the back, which was supposed to work for streaming, like UPnP, DLNA-based stuff, but it doesn't support any useful codec, so that is not even connected. It doesn't have firmware update, it hasn't had firmware update in forever. So essentially the only way to control that is either through CEC or the IR remote. The CEC is an interesting one because when I first started this whole mess, I didn't have CEC control on the NAC because that's an extra. You need to buy the adapter that connects to the CEC customer header in the NAC and then exposes as a USB device, but then connects in turn to the software by a library. And that's a problem. The HTPC is running Kodi, and because it's running Kodi, it doesn't actually let me send messages over CEC if Kodi is running. I could try to write a Kodi plugin for that. That's a different problem and not one that I've been having time to get to. So IR remote is the one thing that I can control the TV with, and IR remote turns to be also what I'm controlling the switch with. Except, turns out that these are different because IR remote have different requirements of frequency and wavelength and stuff. This is 40 kilohertz at 950, not 40. This one. It will work with the right 40, but it is 950 nanometers. And this one is 38 kilohertz at 940 nanometers. Not millimeters, nanometers, slightly smaller. I did manage to use the same IR to send both, but not at the same time. Technically, you can use a variable PWM output to send the thing with both, but yeah, it's iffy. So instead of all of that, use that black one. Instead of all of that, I'm just going for IR decoder replacement, because I'm lucky and this switch actually has an external TRS connector, like an audio jack. But just has the normal T-stop style IR decoder, which ignores the whole frequency modulation, the whole wavelength and everything. It just has a signal modulated there, and just sends the pulses. Like, you'd only care about the pulse length, which makes the whole thing easier to implement, except it needs an optocoupler. But that one is solved. So this one will have its own audio jack with TRS replacement. I can use an IR remote to control the TV, and I can use SOAP protocol. This one I use SOAP over Ethernet. There is already an iPhone module that is called RVX, I think it is. It's a module on PIP. And RVX allows selecting the input for the receiver directly by SOAP, and that's not that's a solved problem. Let's call it that way. All of this is a bunch of separate protocols, none working with the other. So the question became, how the heck do you even talk to this? Well, the answer, what I gave myself, was I'm going to use a NUC. So let me bring in the NUC. And can I actually move the NUC? Oh yeah, I can move the NUC with the... Can I move it with a pen? I cannot move it with a pen. So there we go. The first work with, well, not the first, the second work with Microsoft Whiteboard. I can move these images with mouse, but not with the pen. Not even if I select the thing. Okay. If anybody from Microsoft is listening, please fix this, or at least document it. So we have a NUC, and the NUC can talk with the receiver directly. So receiver, I have an image. So with this one, we can speak SOAP. It even has the RVX library already, so we don't care about writing all of that. It's already in Python, everything works fine. Then we need to speak with the TV, and that came slightly harder because, as we said, this one can only do IR, and it uses the CIRC protocol, which is the Sony IR control protocol. I implemented that with PyCirc, so there is a module now. It's called PyCirc. You can encode the commands, and I found the commands for selecting the input. Many of them were really documented, because the CIRC protocol is the same since the 80s. I literally have a 1989 Sony remote control that works perfectly fine on my TV, at least for the TV side. And I was actually tempted to reuse it to do more controls with that, because, one thing I forgot to say, the NUC actually has its own IR remote sensor as well, so I could use that one to receive the commands from the old Sony remote, but then I realized that it would be slightly easier to just use CEC, because play, pause, up, down, left, right, okay, go back, that's essentially all that there is needed for controlling Kali for me. So anyway, maybe in the future, who knows. The TV controlled by IR remote, that's the easy one. And then the switch, which again I don't have an image for, so I'm going to redraw it here. Yes, and I know that it looks more like a network switch than an actual HDMI switch, but we call it this way, and there you go. We just accept that it is that way. This one speaks something that is not quite the IR remote, but it speaks NAC protocol, which again PyCirc, because I misnamed the thing. Originally I only intended to support the Sony protocol, and then I realized I didn't have the NAC. And the NAC is actually fairly easy to do as well, so yeah. One day I'll rename the module to Python IR remote or something like that. PyCirc will do fine for now. I have support, I have encoder and decoder for NAC now, kind of works. I actually waited 2 weeks to try to get this to work, because it kept failing on me, and then like this past weekend I was like, okay, no, now I need to go and sit down and use my newfangled TRS interceptor for SADE, which I posted on Twitter. I'll show some pictures, and yeah, I put it on. I tried to compare my own code sequence to the original remote control sequence, and it was just, I forgot one post at the end of the thing that just says, yeah, the command is done. Without that, the controller in the HDMI switch doesn't actually do anything. Let me just open the door a little bit because it's getting warm. Without that, it doesn't seem to commit the state, so yeah. So it speaks NAC, and I'm going to use this directly with a TRS connector. So that part is easy. I need an infrared LED, easy. You can buy them off AliExpress, or in my case DigiKey, because I wasn't sure which nanometer I wanted, and AliExpress was a bit iffy on that. You have a TRS connector, you have an opto-isolator just in case. Because yes, supposedly all the ground is grounded together, but let's not be fiddly about that. My first idea was to put an Adafruit feather. I love the Adafruit feather format. They're very nice. CircuitPython makes it very easy to write code for them, particularly for things like this. That's the reason why PyCirc is written in Python. Among other things is I just wanted to use it with CircuitPython at first, so it actually doesn't use a lot of features that could make it slightly easier, but let's not get there for now. The problem with the feather was that if I just put a feather with an airlift feather wing, which is essentially the Wi-Fi, it was a bit messy to send the commands. It's much easier at the point to pull the commands, and yeah, too complicated. I was told that MQTT should solve most of the issues I'm thinking of, but then again, I need to be able to speak SOAP to the receiver, and that one uses RVX, and running RVX on CircuitPython was too much of a mess. And so instead, I'm going to replace this with a USB device. Oh yeah, Snap 2 thing works actually pretty well. And this is going to be a USB device. And I was tempted to use a feather as a USB device as well, except the feather doesn't currently have the ability to receive HID reports with more than 1 byte at a time, which is unused to essentially blink the caps lock and unlock LEDs. I didn't want to go down that road. There is another device also from Adafruit, which is essentially just an FT232, which is just a serial, not quite a serial adapter, it's essentially a GPIO adapter, and that one will just have a FT232 connected to a custom board. And on the board itself, it's just going to be, I don't actually have it here because I just sent them to manufacturer, but it has a TRS jack. Let's go this is TRS. It's a great TRS because that's what I had at hand. And then a 2-pin connector that goes to an infrared LED. and that's 940, no 950, sorry. 950 nanometer, and this one goes to a Y cable, because turns out that's easy. So this one goes into the switch. I painted myself in a corner. So yeah, and this one goes to the original IR sensor. I'll call it T-SOP with quotes because it's definitely not an original T-SOP, but essentially what this has is it's a plus 5 volts ground signal that goes into a TRS, and being just a Y cable, you just get this signal intercepted either from the original remote control or from the board. So that's the board, and this one has a transistor which I don't even remember how to run to draw, to be honest. I think it's this way. There we go, something like this. And then that one goes to the PC. Oh yeah, sorry. And here there is an opto isolator because yes, the grounds should all be the same, because this HDMI switch is actually powered by USB power adapter that doesn't have a ground. All the grounds should be safe to put together. I wasn't entirely sure. The opto isolator is 20 cents. 20 cents is much less, even 10 of them is much less than buying a new HDMI switch if I burn it. So I just opted for the opto isolator and I'm done. That part is the relatively easy part, and the next part is where things will get complicated, which is how the heck am I going to control this? The plan, let me just find some space where I didn't write yet, I'll just go here. The plan is that I will want to have the ability to control this from the smartphone. Oh, and I forgot that I cannot move it with a pen. Smartphone. And then I'll add the NAC because that's the one that does the thing. Which again, it's not connected over Wi-Fi, it's connected over Ethernet, I don't care. The phone is connected over Wi-Fi, so that's not a problem. And just have the interaction mark. And not much for querying, because it's not quite obvious how you query which input is selected on the TV. Over CEC you can do it. I can probably keep track of what I selected, but that means that I wouldn't be able to use the remote. I want to still be able to use the remote. So mostly a one-way system to send commands. And the list of commands is not even that big. I select input, select input. And I want to be able to like volume up, volume. I could send play pause, which might help, but the other thing is the thing that can be play paused or pause played. I have a Chromecast, which like you can already do it from the phone, or I can do it with the assistant, or the Kodi, which I can do from the phone with Core. So I don't need play pause. Technically, I just need the select input and the volume. Practically, I could do anything. Like I could just create the remote because I can send all of the things that the remote sends, but I'm unlikely not going to use the remote ever. The select input though has more interesting because it's an input tree, so it's like if I have a PlayStation 4, for instance, is under the RDX, and so is the HTPC. Let's call it Kodi. and so is, I think, a switch. Okay, let's not talk about the switch because like we already have HDMI switch. Let's say the Xbox 360 is there. And then there is the switch, annoying enough, and as I said, it has a Chromecast, and it has the portal TV, and the TV is connected there. And technically this also has a C64 because yes, I ended up I've been the hipster on this, and they bought a Commodore 64. So the idea will be that the input list you get is this side over here. You cannot see my mouse. This side over here. I'll use the Galaxy name. This one. So the idea is that if you select Xbox, it will select on the TV the RDX and the Xbox all the way. And that's why I will likely end up with a web app, with a relatively simple web app, because that's all you need. You can list you technically can get the RDX to list you the inputs and also the names of the inputs because it has those. Most likely I'm just going to hardcode them because yeah, this is not going to be a high level software engineering, just going to be a web app. So you have your web app server that I'm going to call that way, and it's going to have select input. Actually, it will only have two things, as we said: select input or volume, and it needs, like, these are the actions that we want to have, and then it will have list inputs, simply so that the whichever UI, probably just a simple web app that the phone can open, the list inputs, which will provide the list of fixed inputs, and then it will select first on the TV, when IR to TV. Actually add it now, that's not the TV for now. Or it can TRS to the, well, it should probably TRS to the switch, and it should RDX to the RDX. And that can be just a simple flask at that point. So that part is going to be the relatively straightforward one, in the sense that it's going to be what? 1, 2, 3 flask inputs, so 3 flask endpoints, and then these two can be async. Actually, can they all be async? Probably can they all be async. So let's do it this way. Async. So you don't wait for them. You can run. You can technically run all of these in parallel. No, you cannot run these two in parallel. You can run these two in parallel, but not that one. Like the RDX or one of these two. Not these two in parallel because they go through the same FT232. It doesn't actually have any smart. It actually needs to bit bang the whole thing, which is fine. Like, it's not high precision what you need for that one. Like, when I say not high precision, the first space or first mark, depending on how you look at it, the first pulse that you send of a NAC protocol should be 9.4 milliseconds. The remote sends 9.1, and it's still taken fine. So it's very flexible with these things. As long as the relative marks and spaces are the right shape, it will do fine. So all of these can be async, and that's not a problem. And then you just need to have a simple UI, and literally I could make the thing be a table of, like, I really like the snap to figure, by the way. That part, you need to enable it, just so you know. Ink to shape, sorry. It's also ink to table, let's try how that works. So it will have the inputs, which are big buttons, and it will have Kodi. That's the input to table. Okay, let me not do that. Kodi, Chromecast, Portal, PS4. And when you click on that, it just goes and selects. So this will be HDMI 2 on the TV, RVX 3, I think, and this one will be HDMI 1 because that's where the switch is. So switch 2. And again, all of that can be done either with a request here or straight into the Flask app. It's going to be Flask. And Flask is simply because it's Python, and half of this is written in Python, half of this interacts with Circuit Python. It will do just fine. And yes, all of this could probably be done on a Raspberry Pi as well, because then you wouldn't need the, well, you wouldn't need the FT232, you still will need an adapter because you don't want to compose the IR LED fine from a Raspberry Pi with GPIO. You definitely don't want to connect straight to HDMI switch. So yes, I have hated Python. I still think that the level of Python I've seen before was essentially encoded Python. You can do encrypted parallel. You can do encrypted Python. Brian, if you're listening, you know who you are. I also hated Python 3 for the longest while. It works. Turns out that when you learn it the wrong way, most languages are terrible. So yeah. So yeah, that's the current state of how this is going to look like. I haven't really started working on the code of this. I have all the authorization now, so I can do that. What I can do is I can add a, oh, I need to open Eagle. Do I have Eagle open? Yes. Projects. I can open the schema and show the schema. Like the schema is actually fairly silly. Export image. 600 dpi to the clipboard. Okay. And let's see how this is going to look like. Can I even import here? Indeed. There you go. So this is the current. This is the board from Eagle, and like it doesn't say much because yeah, it's VFT232. Again, it's particularly overkill to use VFT232 just for this, to be honest. I need literally 2 lines to modulate all of this. The FT232H from Adafruit has 17, I think, lines. I could do this with an 8-pin micro connected to a USB, but this one I have and I can make more easily. This one works. And that's essentially all there is about this one project for now. You'll see more soonish. I will probably publish the whole set because I can. And there is no reason for me to keep this private. Yes, it's going to be junky code, but it's fair. If somebody else ever needs any of this, I can pick it up. The RVX stuff is very easy to use. It's actually used by Home Assistant already. And yes, I consider wrapping this all in something that Home Assistant can handle, like an ESP32. But again, that would mean I would need to learn about Home Assistant, which I haven't had the time or the will of in quite a while. So for now, that's going to stay there. Now, since we are only halfway through, let me go and create a new whiteboard. Let's talk about, what's this one? Oh, you can switch between whiteboards. As you can tell, I'm actually, oh no, that's the sync status, I don't care. I'm also learning the Microsoft Whiteboard as I go through this, which is the main reason why I'm doing all of this, given that everybody is remote and everybody's going to stay remote for the foreseeable future. Not having the office to just bring people around and go to a room and discuss everything in front of a whiteboard. Yep, that is actually annoying me and frustrating me, so I'm trying to look for alternatives, and this is an alternative. It kind of works, actually. It works better than I expected, to be honest. So, let's see, what did I want to speak about on this one? Oh yeah, so let me get to a state where I can start drawing. USB monitoring, USB capturing, that's an interesting topic as well, because it's driving me insane. You have, let's say, a computer. I'm going to keep, actually not, let me fetch a few more icons from a noun project. Again, the noun project is awesome to get this kind of iconography. So I'm going to download the PC. And I'm going to download a USB logo. Do I have a USB? You have plenty of USB logos. Let me do this one. Like this icon here will do fine. Okay. And that's this one. There you go. Here we have our PC. And then we have our USB cable. Very big USB cable. If you want to know what's going on here between these two things, this is horrible, but let me go with it for now. No, maybe not. If you want to know what's going on here, you need to use a USB monitor. And you can get this one with USB Mon on Linux. Or you can use USB pickup on Windows. Can't write today. USB pickup Windows. Even Windows 10. And I think Microsoft had their own, and long time ago I used Utilizer, which I don't recommend to anybody. USB pickup works better. So you can get this data out, and you would expect that it's the same data because it's USB, it's standard format. Like this actually is USB protocol. And both of these actually output a pickup ng file. But they are actually different pickup ngs, because this one is a USB pickup ng, and this is the USB Mon pickup ng. Pickup ng is getting the raw data that comes from a kernel from both of those, from the capture driver on both of the two operating systems. And so despite having the same exact information in it, they have different formats. And then there are other ways. You could use instead, let me do this. Total Phase, I think it's one of the company that makes a hardware USB snoop. When you cannot install either USB Mon or USB pickup, or you're going the other direction, or like, there are plenty of reasons why you may want to use a hardware monitoring tool instead of the software one, and that one has its own format, and USB Laser has its own format. They can all be reconstructed in a single format, except Wireshark doesn't. Wireshark supports all of these, but in different ways. So, with what we are trying to do is to read everything with Wireshark. You have multiple formats with different dissector. So one of the things I've been working on was a translator that went from USB peak, no, oh, actually delete it with that, that's interesting. Yeah, there you go. From USB pickup to USB mon mmap. And they start to think that they went the wrong way around. USB mon mmap is the thing that Linux uses. Well, that's the main way you capture USB on Linux, on modern Linux, where you actually care about the data you capture instead of just random. But it's also but it's also a bit of a mess in the sense that these also need pickup ng headers. So the USB mon mmap format. No, stay there. Cute though. Okay. Then USB pickup format doesn't include timestamps, so this one is pew plus pickup ng. USB pickup doesn't include the timestamp in their own. USB pickup is designed to work explicitly with the pickup format. So any information that will be redundant in the pickup ng headers is ignored. The main thing that it doesn't have, USB pickup doesn't include the timestamp in their structures. So this one doesn't have no timestamp. And it is a variable length headers. Whereas USB mon mmap, it has redundant timestamp. But there is a timestamp in the USB mon header, and there is a timestamp in the pickup ng header. I don't think there is any check for them to ever match, and Wireshark uses the pickup ng header one. So Wireshark reads pickup. Other tools may read the header inside the capture, which is actually what my tool used to do. Other tools used the one in the capture because the capture has all the information. The capture has all the information because the capture is just whatever the kernel is sending out. And the kernel is sending out everything it knows, including a timestamp, in a very raw format. Like it tries to do the minimum amount of processing on the kernel level, which is why you end up with USB capture tags that were supposed to be unique according to the documentation. They are not unique. It would be the same between the submit and the callback, essentially the request and the response. But they're not unique throughout the capture because it's just the memory address of the data structure where the USB submit and capture were stored. And yes, there will be the same between the two, but then it will repeat. And Wireshark doesn't know this, so like it has, I'm sorry, duplicate tags, duplicate tags, Wireshark matches them, but matches them, like, you can have the first request being matched with the callback 4 seconds later, but has nothing to do with it. Because it doesn't know that they're documented as being unique, and Wireshark treats them as if they should be, but they're not. So my tools have the ability to just go and retag everything. It used to retag everything with UUID, 128 bits, but the USB Mon format doesn't support 128 bits. It only supports 64 bits for the thing because it's just a pointer, and that's kind of the annoyance there. Let me actually check USB pickup if the format does have such a format. The RPID in USB pickup, like both of these have 64-bit pickup. Like both of these have. Can I move? Let me see if I do this. Again, this is okay. This is me learning how this thing works live, essentially. Very well. So both of these have 64-bit IDs. 64. Let's call them tags. They're called RPIDs in the USB pickup because that's an I/O request packet ID. They are called tags in USB Mon. I don't particularly care. They are the same thing. They are pointers into the memory, and they are not as unique as they should be. According to USB pickup, they can be used to match the request with a response. That's all they say. So yeah. So where were we? Yeah, Wireshark doesn't know that. Actually, I think both of these are duplicate matches, so I can probably move this one on top as well. Okay, this part is actually cool on this type of whiteboards. Wireshark will match the duplicate tags randomly, so my tooling going and retagging this is probably a good idea. There is no timestamp information in USB pickup because everything else, but that's already part of pickup NG, so there is no reason to repeat it. More annoying, USB pickup refers to the Windows DDK, the device development kit, for some of the types, but these are pretty much easy to get, and definitely Wine has a copy that is open source, and I think the Windows one may actually be licensed in a way that you can actually reuse it, but they're just constants, so that's fine. That's not a big deal. And yeah, for both of these, there is no easy way to include. Move this one over. There is no descriptor. Handle. What do I mean? When you connect a USB device, the computer asks for a descriptor to know what are you, what's your product ID, what's your vendor ID, and there is nothing in either of the format that will call out these. Like there is no block on the pickup NG that includes all the descriptor of the devices that you met during the capture. There is no descriptor of there is no call out to these are the product IDs that we found in the system before the capture even started. The way Wireshark handles this, or the way lib pickup, TCP dump, T-Shark, Wireshark handle all this is when it starts the capture on Linux, right after it starts the capture, it goes and just does a reset on the bus and requests everything. So what you end up with is, let me make some space. Go. So the sequence of operation on Linux, at least, I haven't seen how USB pickup does this on Windows, but on Linux this is what happens. So you open dev USB on 0, 1, whatever it is. Sorry, something just seemed to have crashed somewhere, I don't know. Is something going on? Sorry, folks. Be right back. Yeah, sorry folks, some problem here in the flat, nothing wrong, just smashing. Anyway, where were we? Yes, so when the first thing that you need to do to capture USB on Linux in a way that Wireshark supports it is you open the USB mon, and then you have two options. You either query or set the buffer size, ring buffer size. And then you send an IOCTL, and actually that's also an IOCTL, so let's not put this in IOCTL. And then you query a capture, essentially. Query. And what this does is it returns you with an array of pointers within the of offset within the buffer of where the data the capture structure with the data following is, and the lengths and all the everything that's happening there. And in parallel with this, so at this point, you need to do an USB reset, or run a query USB devices. And what this does, it essentially does the whole get descriptor thing, that it mimics what the the operating system does the moment when you go and connect. Oh, just realized I was not showing the right window. Yeah, that's the right window. Yeah, so you need to do in parallel the USB reset, but essentially just goes and resets all of the devices, or queries all of the devices to get the configuration, the product IDs, the vendor IDs, the HID descriptors for the HID devices, and all of that actually feeds into, like, this one then quits, and this loops instead. And all of that essentially feeds back into the capture. And the capture file will have all of the descriptors for all of the devices, because you reset the bus. For that to work, like, all of that needs to be at the start of the capture for Wireshark to know that those are the devices that are going to be involved in the captures. So it's a bit fiddly. If for whatever reason you start getting data in the middle of that bus reset, which I've seen happening only once, the Wireshark doesn't actually know what's going on there, and it also means that you need to exactly implement it this way. If you try to implement it just by reading at the documentation, yes, you'll get a capture with all the valid data you want, but you're not going to be able to get Wireshark to tell you what's going on there. You may be able to still parse it if you know what's going on. Most of my tools just take a device address and then they assume that you told them to look for the right data, but there is no guarantee of that. Yeah. This is the logic flow, but if we try to look at it in a different way, this way, we can look at this with like the pickup kernel and then USB devices. No, actually, that's not the way I was supposed to draw it, right? This is more UML-y. You don't know UML, you don't know what you're missing. This is great, particularly when you're talking with clients that are asking you to show them something after 3 days you started working on a project, when you still are capturing the requirement, and what you show them is drawings, and it works. So pickup sends an open to a kernel, so this is going to be the open. Kernel returns a file descriptor, and then you get the first IOCTL, and you get a buffer size. Well, let's call it the buffer size. I can draw better. I'm sure I can draw better. And that's a circle. And then you get the file descriptor, as I said. And then you can set the buffer size or query the buffer size. So I'm going to call this Q buff size. And you get the buff size back. And then you mmap, and you get your memory area. And then you continue the IOCTL to get the arrays, and when you read them off the mmap, so you don't actually need to put it here. But then what you need to do is to do a reset, which then means the kernel will go and will get the descriptor, and all the rest of the USB handshake, and like in parallel you keep reading. So once you doing this is all the IOCTL block. The reset is in parallel. It's not great. It works. That's what we've been doing for all the past years. But I really wish there was something better, something more straightforward. There is no way right now to set filters. Oh, I'm out of the space over here. There is no way right now to set filters, but what I really would like is if you still have your capture software, capture software, and your kernel. You ask to open captured, or rather, sorry, let me find. What I would like to be able to do is send the BPF program. And then requesting. And let the kernel just stream you the data, which should be possible. It just hasn't been done. And if I were to do something like this, start to work on this myself, I will probably rethink the current structure and go from the current fixed size header structure-y thingy into a more USB pickup similar, like if not the same, like it technically can probably use the same, just needs a little bit of copying. Like for the isochronous stuff, it has separate isochronous headers. For the Vulkan for the Vulkan control, it has a separate thing for the stage and that's it, because that's all it needs essentially. All of that information is only needed for certain types of packets, so why not just have it there? And hopefully with the BPF on the capture, you wouldn't need to have a separate device for each bus, USB bus channel that you have, USB bus controller. And you will be able to say, well, I just want the data coming from this device, which is not my keyboard, or not my mouse, or not my USB token, where all the possible cryptography operations are happening. Whoops. I've been very careful not to share capture streams of any capture that I may have made where my USB token was connected, because I have no way to filter. My tool supposedly can filter it now once I manage to get something that Wireshark can work on. So yeah, now it's been an hour, so let's call it an end for tonight. But if there is more interest on this, please let me know. I hope I can actually get a copy of the video and upload it as well separately, and I'll post it on the blog eventually. But if there is interest, just let me know, give me a heads up somewhere. I don't know if this thing has a like or anything. And then I'll be doing this again, let's say in 2 weeks, if there is interest. Or next week if there is a lot of interest, but I don't think there is going to be. If there is a bit of interest, I will do this again in 2 weeks. Have a nice heat wave, everybody in Europe. Have a nice rest of the weekend for everybody else. Bye!